trying to get enough done to where we can have a test before the break. And also, the other stuff in this chapter is really review of algebra, which we will do periodically through the year. Maybe on some dead time before another break, we might do some worksheets over slope and, equations of lines and things like that. But this falls in with what we've been doing, which is parallel lines being cut by a transversal. Except we're going with it from another perspective now. To review what we've done before, if you have two lines that are parallel, okay, which those two look to be, then you draw a transversal, which is a line that intersects both of them. An interesting thing happens. What happens? These four angles created up here are mirrored by these four, aren't they? And it basically always works out like this. If I can get some pencil lead. No, I have some if needed, or I can just go on to using pen. All right. I want you guys to remember this. And I did this more in third and fourth hour. But basically, the situation when these two are parallel, it always works out like this. This angle is going to be congruent to that angle, and that one's going to be congruent to that one, right? Because they're vertical angles. But if you were to just go around it in the circle and end up where you started, one mark, two mark, then go to here, what's next? One mark, and then what? Two mark, and then what? One mark, two mark, one mark, two mark, one mark. Okay? Of course, the marks are equal to each other, right? I know that looks weird writing it like that. And if they're different marks, what do they add to? 180. Because this represents that this is congruent to this, congruent to this, congruent to this. So when you're creating these equations in this from yesterday's stuff, if you'll go and mark your situation, you should be able to look at these, and if you have something for this one, say this is triangle, and then this was circle. What do you know about that? If you wanted to create an equation, how do they relate to each other? Are they equal, or do they add to 180? So triangle equals circle. You guys get what I'm getting at there? That it's a general concept that it happens every time this way. When these two lines are cut by a transversal. If the measure of this angle was square, what do I know about triangle and square? Triangle plus what? Square equals. That's the concept here. How easy is that? Every time you find out these two are parallel, these are transversal, you can go around and mark them right now, and you can create, all you got to do is realize that they have the same mark. If you've labeled them with the same mark, then they're what? They're equal. If you've labeled them with different ones, then they what? They add to 180. It's that simple. Okay? Now, what we're learning today, and this is the review, and these two are here are what? Alternate what? Interior angles. These are what? Alternate interior angles. These are alternate exterior. And these are corresponding. You need to know how to, you need to understand this concept, but you also need to be able to classify them by the type of angle they are. Okay? Now, what we're going to talk about today is proving lines parallel. So I've got two lines drawn here. They are not labeled that they are parallel. I've got a transversal drawn. I'm going to make you guys a list here, and let's label this angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. You can prove that L is parallel to M if one of the following happen. One, pair of alternate interior angles are congruent. So if you can find one pair of alternate interior angles to be congruent, guess what you can say? The two lines are parallel. So see how we're going opposite? In the last section, I told you these two lines are parallel. Tell me what happens. This section, I'm saying, hey, these two angles are congruent. Does that mean these two lines are parallel? We're going the opposite. A pair of alternate exterior angles are what? Congruent. You can find just, and it's just one of these has to happen. A pair of what? You think I'm going to say next? Corresponding angles are congruent. I didn't say you had to find all of them, did I? Just one pair. A pair of consecutive interior angles are what? Nope. Those are the ones that are different, right? You can prove any of those to be true, then you know the lines are what? Parallel. Get your red books out. What you'll find is a lot of these problems are exactly like the problems in 3-2. Because they'll say find x so that L is parallel to M. Some aren't. Has everybody got that down? Well, let's look at this first bunch right here. It says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies it. Okay, they want to say, hey, if I told you this, would this mean that these were parallel, or so on and so on? Well, anybody have any guesses? What's the first one? Angle 3 congruent to angle 7. Mm-hmm.
Alternate interior angles.
What do you guys think? You guys agree? I do. See, because angle 3 and angle 7 are alternate interior angles. But they want us to determine which lines are parallel. So this being congruent to this, what two lines does that tell me is parallel? With respect to which two angles are my parallel lines then, and what's my transversal? My transversal is what? L. So my parallel lines have to be what? A and B. So that tells me that what? A is parallel to what? And the actual name of the theorem is the converse, because that's exactly what it is. Take the headphones off, please. They're not on, are they? They're not on, are they?
They I mean, I can still hear you.
Put them on my desk, please. Ah, the thing that was playing, whatever it was playing as well. Do appreciate you being honest. Okay, next one. Nine congruent to 11. How do they relate to each other? Well, which two lines does that prove are parallel? Yeah, it's still M's the transversal and A and B are the two lines being intersected, right? So it proves that A is parallel to B. Let's jump down to 3. Angle 2 being congruent to angle 16. So that would be angle 2 being congruent to angle 16. How do they relate to each other?
Alternate exterior.
Which two lines does it prove being, which one's my transversal?
A.
So the lines being parallel are the two it intersects, which are?
L.
So that this is telling me that L is parallel to M. Last thing here, angle 5 and angle 12. It's saying these two add to 180, correct? So that makes which ones, so this is what?
Second interior.
I forgot to write converse. So, which one's my transversal? B, which two lines does it intersect? So that's saying that what? L is what? Those are the two that have to be parallel. That's a pretty easy concept, isn't it? Now, these problems down here, I'll zoom it back out and freeze it if you didn't get to write that down. All these problems are saying is find x so that L is parallel to M. So it's saying this has to be parallel to this. So is this really any different than the problems you did in 3-2? No. All you got to do is go around, like I said, and do this. That one's congruent to what? That one. 2 marks. This one would have to be what? 1 mark. 2 mark, 1 mark. 2 mark, 1 mark. Well, I have a 1 mark and a 2 mark are my two that I have here, right? So they're different. They're not the same. So what do they have to do? Add to 180. So 2x plus 6 plus what? 130 is equal to what? You can solve that equation, can't you? Everybody don't worry about writing it down. Pay attention. Okay, if I made this my 1 mark, what would this have to be? 2. This one? This one? This one? This one? 1. What would this one have to be? This one? This one? See how easy it is just to go around like that? Okay, I've got a what? 1 mark and a what? 1 mark, right? 1 mark and a 1 mark, right? So, are they equal or do they add to 180? So there's your equation. 3x plus 10 is equal to what? 4x minus 10. You guys see how easy this can be? Let's go to this one. I'll start this being a 1 mark. That means this one's a what? 1, 1, 1, 1. Okay, the two things I'm given here are 1 mark and what? So are they the same or do they add to 180? So what's my equation? Isn't that awesome? Let's go down here. This is a 1 mark. What's this? Okay, I've got, it's these two that they're talking about. You guys see those arrows? So 1 mark and how do they relate to each other? They add to, so 3x plus 10 plus 5x plus 18 equals 180. I hate that this is kind of a gimmicky way to show you how to do it, but at the same time, do you understand that this is the same situation? Everything, the only thing that changes is where it is what they give to you. Because when two lines are parallel and they're cut by a transversal, it always works out like this. 2 marks, what? Or 1 mark, 2 mark. 1 mark, 2 mark. 1 mark. So I have what? 1 mark and a, how do they relate to each other? And here, you didn't even really need, you don't have actually a theorem for this, do you? Basically, you know, this is congruent to that, and those are linear pairs, so they add to 180, right? But if you're going to mark it like that, you don't need to go through all that, do you? You know it's the one that's not the same as, so you know they have to add to 180. 1 mark, 2 mark. 1 mark, 2 mark. 2 mark, 1 mark, 2 mark, 1 mark, 2 mark. 2 mark, it doesn't matter which one's the 1 mark, which one's the 2 mark. You just know that you're just basically marking the ones that are the same and the ones that are what? Different, and using 1 mark for this type and 2 mark for this type. So I could, you know how I did this right here? I could start out like this, because this is different. I could go, okay, that's my 1 mark, 2 mark, 1 mark, 2 mark, 1 mark, 2 mark, 1 mark, 2 mark. You see how it works out the same? The time before I did it, this was a 2 mark and this was a 2 mark. Well, this time I did it, this is a what? 1 mark, this is 1 mark, but it still works out the same, that you see that these are what? The same. So your equation is 4x is equal to what? Now, but like I said, as much as you can do it that way, you need to be able to recognize that these are what type of angles. This is what? Alternate what? Exterior angles. Okay? You guys think we can do this? What does Canvas say? Do I have any people who need help on Canvas?
Tomorrow work day.
Yes. Canvas says that we're going to do numbers 7 through 21, 23, and 25 through 28. Write problems, draw figures, show all steps and work. You think I'm going to give you credit if you send me something with just answers and you don't write the problem? No. This is all due Friday. Oh, I did. I'm sorry. I'll zoom out. My bad. Why don't you guys make sure you write down those equations so you have a kind of a template for how to do each one. Okay?